6 hours of bisecting, only to find the exact same null pointer error that was fixed 3 weeks ago. The hotfix never made it to develop. Let's break down Git tags and releases, how it works, and the exact mistake behind that failure. A Git tag is a named reference to a specific commit, typically used to mark release points like v100. Unlike branches, tags do not move, they permanently point to one commit. There are 2 types: lightweight tags, which are just pointers, and annotated tags, which store metadata like tagger, date, and message. For releases, always use annotated tags. Here are the essential tag commands. Create an annotated tag with a and a message. List tags with a pattern, view details with Git show, and push tags separately. You can check out a tag to a detached head or create a branch from it. Deleting tags requires both local and remote commands. GitFlow uses 5 branch types. Main and develop are permanent. Main holds only tagged, deployed releases. Develop is the integration branch where features merge. Feature branches are cut from develop, release branches from develop for stabilization, and hotfix branches from main for emergency fixes. Each has a strict source and destination. This sets up a GitFlow project from scratch. After initializing, create the develop branch. Feature branches are cut from develop. When merging back, always use noff to preserve the feature's history with a merge commit. Then delete the feature branch. Hotfix branches are for emergency production bugs. They branch from main, not develop, to get a clean copy of production. After fixing, merge to main and tag a new patch version. Then, critically, merge the hotfix to develop as well. Skipping this step is the most common GitFlow mistake. Here's the complete hotfix cycle. After branching from main and applying the fix, merge to main and tag. Then immediately switch to develop and merge the same hotfix there. This ensures the fix is preserved in the integration branch for future releases. Finally, delete the hotfix branch. This is the same issue we highlighted at the start. Here's exactly why that happened. The hotfix branch was merged to main and tagged v101, but the developer forgot to merge it into develop. 3 weeks later, when develop was merged to main for v110, the buggy code from before the hotfix was reintroduced because develop never had the fix. The team spent 6 hours bisecting before discovering the root cause. The root cause is that the hotfix branch was merged to main, but not to develop. So the null pointer error fix was missing from develop and reappeared in the next release, v110. The fix involved reverting the v110 deployment, then cherry-picking the hotfix commit into develop using git cherry-pick hotfix SHA. After that, v110 was retagged with the fix. To prevent recurrence, a CI check was added that verifies hotfix commits appear in both main and develop after the hotfix branch is deleted. This is the exact mistake from the incident. The developer merged the hotfix to main and tagged it, but never switched to develop and merged the same fix. As a result, develop remained buggy, and the next release from develop reintroduced the same null pointer error. If you omit noff, Git performs a fast-forward merge, absorbing the feature commits into develop's linear history. This makes it impossible to see which commits belonged to which feature, and Git bisect cannot isolate which feature introduced a regression. Tags are immutable contracts. Force bushing a tag silently moves the release marker, breaking every build, deployment, and rollback that references that tag. If you need to correct a tag, delete it locally and remotely, then create a new tag with a different name. The GitFlow init D command uses default branch prefixes, feature, release, hotfix. If your team uses a different convention, e.g. bugfix/, you must configure these manually via GitFlow init without D and answer the prompts. The defaults are fine for most teams, but be aware that D skips the interactive configuration. The article mentions adding a CI check to verify hotfix commits appear in both main and develop. Here's a concrete GitHub Actions workflow that runs after a hotfix branch is merged to main and checks that the same commits are present in develop. If you must delete a tag that has already been pushed, e.g., tag the wrong commit, coordinate with your team first. Anyone who has fetched the tag will retain the old reference until they explicitly prune it with git fetch prune origin, ref/tags/*, ref/tags/*. Silent tag deletion can cause confusion and deployment mismatches. When debugging a regression, first check if the hotfix commit exists in develops history using Git log. If missing, cherry-pick it. If the release already shipped, revert the deployment, backport the fix, and retag. Prevention is key. Add a CI check that verifies hotfix commits appear in both main and develop. Let's run through some common interview questions. What is the difference between GitFlow and GitHub Flow? GitFlow uses 5 branches for scheduled releases. GitHub Flow uses 1 main branch for continuous deployment. Why must hotfix branches merge to both main and develop? Skipping develop causes the bug to reappear in the next release. When should you choose trunk-based development over GitFlow? When deploying multiple times per day with feature flags. And a few frequently asked questions. What is a Git tag? An immutable pointer to a specific commit used to mark releases. Can I move a tag? No, tags are immutable. Delete and recreate if needed. What happens if I skip merging a hotfix to develop? The bug will reappear in the next release from develop. To recap, Git tags are immutable markers for releases. Hotfix branches must always merge to both main and develop to prevent bug recurrence. Use NoFF on all merges to preserve history. GitFlow is ideal for scheduled, versioned releases. Keep feature branches short to avoid merge conflicts. Ready to go deeper? Up next, resolving Git merge conflicts, then Git hooks explained, then Git clone. Clone a repository step by step. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.